Hello Year 5, this is a special music lesson for your space topic this week. In today's video I'm going to ask the question, can you hear sound in space? In order to answer that, we're going to look at how sound is created, how sound travels, and then whether you can hear sound in space and why that might be. Okay, stay tuned, here we go. First of all, we need to understand that sound is something that travels. It travels from where the sound is created, its source, to where it is received, which is normally our ears, but could also be a microphone or a sound sensor. So if I clap my hands, the sound travels from my hands to my ears. It doesn't just travel to my ears, the sound goes out in all directions. If I make a bigger sound, like on my didgeridoo, everyone in my house will hear the sound. But the sound bounces back off walls, so people who are not in the same room won't hear the sound so well. So what is sound, and what is it that is travelling, and how does it travel? This is where it becomes very interesting, and this is the bit that will answer our later question about sound in space. First of all, sound waves are made up of vibrations. Vibrations are made on different instruments in different ways, and can be different pitches, but each vibration travels in the same way. If I tap a tambourine, the metal cymbals hit together and cause very small vibrations. If I play my recorder, the air goes down the recorder and bounces off the walls inside, causing vibrations. If I play my ukulele, the strings vibrate as I strum. All these vibrations produce the sound waves, and the waves then travel through the air around them. Now normally our air is full of molecules or atoms. Molecules are tiny things that we can't see, that are all around us. These atoms and molecules are really important for helping sound travel, because the sound waves bounce off them. If there are no molecules, the sound waves can't bounce anywhere, and so there is no sound because they can't travel to our ears. We'll come back to that in a bit. Remember, when the sound travels from its source to a receiver, the sound waves are bouncing off all the molecules and atoms in between. Now we have to have a look at what space is made up of. Space is a near perfect vacuum. A vacuum is where there is no atmosphere, no air, no atoms or molecules. This is why we cannot breathe in space. There is no air for us to breathe, not even bad air that would kill us, just nothing. Except that is not entirely true. Space is a near perfect vacuum, but not a complete vacuum. Let's look for a minute again at our Earth atmosphere. We have in the air around us about 10 trillion molecules per cubic meter. That is a huge number. It's impossible to even imagine what that means, but it means basically the air around us is full of molecules and atoms. This is what a cubic meter looks like, and it means there are trillions and trillions of molecules and atoms inside each bit of air of this size around us, or any other material at all. Yet if we look in space, there are a tiny number of atoms, less than 10 atoms in fact per cubic meter. So imagine that big box again, but with less than 10 tiny atoms inside this time, instead of trillions and trillions. So this is why space is called a vacuum, because there are not enough atoms to do anything in space, and so effectively it is just a big emptiness, or a vacuum. As far as sound waves are concerned, they cannot travel between those atoms in space, because the atoms are too spread out and just floating randomly, instead of being tightly packed like here inside the Earth's atmosphere. The sound waves just cannot bounce off them, and so we end up with no sound in space. So what can you do at home as an experiment to learn about this? Well, we can explore how sound travels by looking at how it can travel through different materials. Actually, air is not the best transmitter or conductor of sound. A conductor is something that something else can travel through. Solids are better conductors of sound than air. We talked earlier about how walls can bounce sound back off them. But if the sound was within the wall, then it would travel all the way through the wall and people would be able to listen to it by putting their ear up against the wall. This is why sometimes in films people put their heads down to the ground to hear an advancing army, for example, because the sound vibrations of a large number of people either marching or galloping on horses will travel through the earth. So what can you do at home to experiment and find out more about this? Well, metal is a really good conductor of sound, so here is a really simple experiment that you can do. Tie a long piece of string to a large metal spoon like this. So just a spoon from the kitchen and a long piece of string attached to it. Do make sure you've got permission to borrow the spoon before you do. Now swing the spoon gently against the wall. Let's try it against this wall here. you should get a dull ringing sound when it hits the wall. The bigger the spoon, the better the sound will be. As metal flexes, it's ever so slightly flexible, so it flexes when it hits the wall and it creates the sounds that we need. So it's very good for creating those musical vibrations. Now do that a few times and have a listen and see what sort of sound it makes. Now that we've done that, we're going to wrap the other end of the string around our finger like that, so it's nice and tight. But still leave a bit of string there so it can swing nicely against the wall. Now what we're going to do is we're going to swing it against the wall again, but this time I'm going to put my finger in my ear. So I'm just going to allow a little bit more string. I need quite a bit of string still to swing it, but be able to put my finger in my ear. Let's try that and see what happens. Now it's very interesting because now I'm not just getting the sounds through the air around me, the sound is actually carrying up the spoon and through the string and down my finger into my ear. Now if I put my other finger in my other ear while I do it, I get an even stronger sound coming through the spoon itself. So what we're learning here is that sound doesn't just travel through the air around us, but sound will also travel through other materials, in this case a metal spoon and the string. Now make sure the string is wrapped nice and tight around your finger, otherwise it won't travel, the sound won't travel very well. Make sure your finger's firmly in your ear so that the sound travels all the way in and you can get a really good sound. You should hear, as well as the normal clanging of the spoon on the wall, you should hear quite an interesting vibrating sound through your finger from the spoon itself, as those vibrations travel straight up the spoon and string and into your ear. So what I'd like you to do is I'd like you to write down what you find out when you do that. How does the sound compare when you put your finger in your ear to when you did it just banging the spoon against the wall the first time? How does it sound different, and what do you think you've learnt from that? Also, maybe try some different materials, try a wooden spoon or some other things, but do check that your parents are happy for you to do that before you go taking anything from the kitchen. Okay, see what you can find out, write it down and send it to me on Class Dojo. So there we are. Now we know why there is no sound in space. Space is nearly a complete vacuum, which means there are effectively no molecules or atoms in space, only a tiny, tiny number, as we saw. When sound is created, the sound waves travel from the source, where it was created, to the receiver, our ears or a microphone, where they are recorded. Sound waves travel by bouncing off the molecules around us, but there are not enough molecules in space for this to happen. Sound waves can travel through solid materials as well as through air or water. So there we are. I hope you have enjoyed our lesson on sound in space and enjoyed learning all about how sound is made and why there is no sound in space. Do have a go at that experiment yourselves at home. Don't forget to send me your answers and tell me all about what you discovered for yourselves. Do look after yourselves and take care, and I'll see you next week. Goodbye.